App service backups provide a robust mechanism to protect websites and web APIs from data loss or accidental configuration changes. Through the backup mechanism, administrators can store essential artifacts, such as application files, databases, and deployment configurations, in a secure location. This strategy ensures the preservation of business continuity and the swift restoration of application environments following disruptions. Once a backup is created, a recovery action can revert the environment to a previous, stable state, preventing extended service outages and meeting compliance requirements. Regular backups complement the existing Azure Compute Resource deployment strategies, ensuring a consistent safety net for critical services. By scheduling backups, organizations can proactively handle potential data issues without disrupting their overall deployment lifecycle. Understanding backup concepts is crucial for maximizing Azure App Service reliability, especially when deploying and managing complex workloads. Azure App Service Backup is available under specific tiers, ensuring that organizations have the necessary features for data protection. The basic, standard, premium, and isolated app service plans typically support this capability, while free and shared plans do not. This arrangement allows administrators to align the plan selection with production-grade features, including backups. When choosing a service tier, it is vital to balance budget constraints with the need for thorough data safeguards. Each tier also enforces different limits for backup frequency and maximum retention. For instance, standard and premium tiers permit more frequent backups and expanded retention policies. By understanding these differences, teams can plan a suitable backup schedule that meets both compliance requirements and operational needs. Ensuring an upgrade to a supported tier before implementing backups is crucial for a seamlessly integrated data protection strategy within the broader Azure ecosystem. An automated backup schedule is central to maintaining consistent data protection for an app service. Within the Azure portal, administrators configure backup settings to run on specific intervals, whether daily or weekly, in line with business requirements. This scheduling includes selecting the site content, associated databases, and storage location. By eliminating manual intervention, automated backups reduce the risk of human error and create a predictable, traceable process. Additionally, integrating scheduled backups into a broader disaster recovery plan helps align with established recovery point objectives. Scheduling around peak load times minimizes performance impacts that might arise during backup operations. Administrators can also define custom retention periods, ensuring alignment with organizational policies for data storage and disposal. Ultimately, a carefully planned backup schedule offers minimal disruption to services, stronger resilience against data loss, and the ability to restore rapidly in response to unexpected incidents. Configuring a backup through the Azure portal is straightforward. First, open the App Service resource and select the backup option. Enable backups by choosing a storage account container as the destination. Then provide a backup name and define the backup frequency. Next, specify retention periods to limit how long each backup remains stored. Administrators may also include databases associated with the web app, ensuring application consistency. Azure compresses these backup files by default, conserving storage space. Once settings are saved, the portal displays status updates for scheduled and manual backups, as well as log details about backup size and timing. Administrators can initiate on-demand backups at any point, should an emergency or unexpected change occur. This user-friendly, visual approach helps smaller teams or newly deployed environments establish consistent backup practices without needing advanced scripting or command line expertise. For more advanced automation requirements, the Azure CLI offers a powerful way to configure backups from the command line. Ensure the CLI is installed locally and authenticated with the necessary permissions. Users can set rules for storage location, databases, backup frequency, and retention by using commands like AZ-web app config backup create. This approach seamlessly integrates with DevOps pipelines or automated scripts, enabling backups to be consistently applied across multiple environments. Combining Azure CLI with IAC solutions like ARM templates or bicep files further refines the deployment process. Below is an example of creating a backup using Azure CLI. Bash AZ web app config backup create / resource group my resource group / name my unique app name / container URL https://mysteraccount.blob.core.windows.net/backups / DB connection string server equals my server. Database equals my DB. User ID equals my user. Password equals my PWD. / frequency 12 H / retention 30. This command schedules backups every 12 hours and retains them for 30 days. App service backups can occur on demand or follow a set schedule, commonly referred to as a backup policy. These policies detail when backups happen, which files or databases are included, and how long each backup remains available. By aligning backup triggers with business cycles, organizations secure critical data around peak usage times. Higher traffic or transaction-heavy apps might need several backups daily, whereas smaller applications could opt for weekly or less frequent backups. Azure Portal offers a clear view of current backup settings, making it easy to adjust triggers as requirements evolve. In more complex environments, these triggers can be integrated with event-driven architectures, where successful or failed backups generate alerts or initiate follow-up workflows. As a result, well-defined backup policies and triggers avert overlooked data protection intervals, ensure accountability among stakeholders, and maintain alignment with operational best practices for robust cloud deployments. When configuring backups for an app service, data security becomes imperative. Azure encrypts data stored in Azure Storage by default, safeguarding backups at rest. Administrators seeking greater control over encryption can use customer-managed keys, which reside in Azure Key Vault. This enables oversight of the cryptographic processes that protect backup files. Building on existing TLS configurations in app service, such layers of encryption deter unauthorized access and ensure compliance with stringent security standards. Additionally, role-based access control, RBAC, limits backup configuration privileges to specified users or groups, enhancing overall security. In regulated sectors, advanced features like Azure Private Link can route backup traffic through private networks, thus reducing exposure to public endpoints. While encryption ensures confidentiality, administrators must also carefully manage keys to prevent accidental lockouts that impede restoration. Combined with other protective measures, robust encryption strategies foster trust in the cloud's resilience. App service backups typically use blob storage accounts or recovery services vaults as their destination. Storing backups in a dedicated storage account or separate container can isolate data and simplify governance. Organization-wide policies can enforce encryption at rest, hierarchical namespace usage, or automatically move older backups to cooler tiers for cost savings. In scenarios requiring advanced backup management, a recovery services vault integrates with Azure Backup for centralized control, extended retention, and more detailed reporting. This approach may also support cross-region backups, offering geographical redundancy. It is essential to label and tag each storage resource correctly, simplifying administrative oversight and usage tracking. Additionally, organizations should consider network and firewall settings to allow safe and secure data transfer during backup. By implementing sound storage configurations and policies, teams reduce the risk of accidental overwrites, manage long-term costs effectively, and maintain data retention compliance across the platform. Regular testing of backups is a key step in ensuring data integrity and seamless restoration. A typical test procedure involves a partial or full restore into a sandbox environment, verifying that all site files, databases, and configurations function as expected. Automated scripts or manual checks might validate database schema consistency, confirm file integrity, or ensure rolling logs match the production environment. Such validation identifies corruption or incomplete backups before a crisis occurs. Furthermore, reviewing backup logs indicates potential network bottlenecks or permission errors that could compromise future operations. Time-based metrics, like the duration of each backup and restore cycle, can offer insights into optimizing the overall process. In complex systems, administrators may schedule monthly or quarterly validation drills, integrating them with compliance audits. Keeping a systematic record of these validation results helps demonstrate the reliability of the backup strategy and instills confidence in overall disaster recovery readiness. Restoring from a backup is crucial in reversing unintended changes or retrieving data lost to failures. Within the Azure portal, administrators can navigate to the backup blade of the target app service, select the relevant restore point, and specify if the restored site should overwrite the existing one or create a fresh app service instance. This process retrieves both site content and database files, ensuring a coherent environment. Restoration times vary depending on backup size and network performance. For command line enthusiasts, the Azure CLI or PowerShell modules provide equivalents, letting specialists script or schedule on-demand restores. Logs in the Azure portal track the progress of the operation, noting any encountered errors. After restoration, administrators should test the site thoroughly, verifying user authentication, database queries, and other metrics. Properly managed restorations let teams recover from application errors or security incidents, preserving productivity and business continuity. Despite careful planning, backups and restores can face complications. Missing or incorrect storage account configurations are a frequent source of error, as are insufficient permissions granted to the backup process. Monitoring the Azure Activity Log often sheds light on the error source, allowing administrators to identify failed operations quickly. Storage container misconfigurations may also hamper backup completion. Restricted network rules or firewall settings can interrupt data transfer. Large backups might exceed timeouts, requiring a combination of schedule adjustments and optimized compression settings. Database connection strings must be validated to avoid partial backups. Where permission denied, errors arise. Verifying that both the app service and administrators have the correct RBAC roles often resolves the issue. Logging and alerting mechanisms through Azure Monitor can preemptively flag failing backups. By following systematic troubleshooting steps, administrators can maintain a reliable and predictable backup workflow for their app service. Automating backup processes promotes consistency and reduces manual overhead. DevOps teams often embed Azure CLI or PowerShell scripts into continuous integration and continuous delivery pipelines, ensuring that each newly deployed app service includes proper backup configurations. Azure Monitor complements these strategies with alerting capabilities. A prompt notification can be sent via email or messaging platforms when a backup either fails or exceeds a predefined duration. Logic apps or custom webhooks can further streamline incident response, triggering remediation workflows automatically. This level of automation encourages standardized practices across multiple environments, helping organizations meet service-level agreements more reliably. Additionally, operational dashboards in Azure provide real-time insights into backup success rates and storage usage trends. When combined, automation and continuous monitoring bolster data protection outcomes, keep teams informed of backup statuses, and reduce the risk of unnoticed failures that could compromise an application's overall resilience. Network paths and access control policies fundamentally shape the security of app service backups. Administrators can utilize service endpoints or private links to confine backup traffic within a virtual network, mitigating exposure to public internet threats. Managed identities further protect credentials, eliminating hard-coded secrets or tokens embedded in scripts. For each backup process, role-based access control RBAC, assigns distinct permissions, ensuring only authorized personnel can modify or delete backups. In highly regulated environments, multi-factor authentication for administrative roles can provide an added layer of protection. Additionally, secure firewall rules in the storage account can prevent outbound backups from being redirected to unauthorized endpoints. Incorporating these measures into a layered defense strategy safeguards data integrity from creation to restoration. When combined with encryption protocols and log oversight, stringent network and identity controls effectively manage risk, preserving trust in the backup framework. Optimally configuring app service backups depends on application type, frequency of data changes, and compliance demands. Transaction-intensive sites might require multiple daily backups to minimize data loss risk, while less active services can align with weekly schedules. Where compliance or legal requirements mandate extended retention, a recovery services vault can store backup points beyond the typical short-term period. For highly sensitive data, encryption using customer-managed keys can strengthen security assurances. Incorporating backup tasks into infrastructure as code ensures consistent replication of best practices across new environments. Administrators should conduct periodic test restorations, verifying that each backup is valid and recovers smoothly. Large, regulated enterprises may also maintain separate resource groups for backup resources to simplify audits. With robust scheduling, careful data segregation, and routine validation, organizations maintain resilience against operational mishaps and malicious threats. By following these measures, Azure App Service backups become an integral component of a reliable cloud strategy.